And if all parts of the mixture look the same, that means uniform, and that's homogeneous, okay? So just like salt water, this is salt water, it's homogeneous, okay? Are these put together physically or chemically? Physically, right? So we can separate them physically. But if I pour this through a filter paper, or I pour salt water through filter paper, what happens?
It just goes through it.
Nothing happens, it goes through it, okay? Did I show you that last week?
Yeah.
I did, right? Okay. So what are we going to do? How are we going to separate the water and the salt? Hold on. Raise your hands. How are we going to separate the water and the salt from each other? Xavier. Evaporate the water. We're going to use the boiling point of water. That's called distillation. We're going to take a field trip to the back room and I'll show you how the distiller works. It's on right now. So we're going to boil the water. I'm going to do this today. I'm going to boil it while class is going, and then hopefully at the end you'll see there should be salt left behind. Just proving it to you, because we can say it all we want. I want you to see it, okay? So that's how we separate homogeneous, and I know we wrote that. I think we did. What type of mixture is this? Heterogeneous, because it has different phases, different parts. You can see the different chunks. It's not uniform. Uniform homogeneous, not uniform heterogeneous, okay? One phase, one part, it looks like it's all one thing. That's what phase means. This has multiple phases, multiple parts, okay? Questions with any of that? All right, so before we actually take notes, let's go look at a distiller and then we'll boil this. This will not take too long. First, let's take a pit stop at this boiling water here. Okay, so this morning I poured the copper 2 chloride solution on here to prove to period 2 that this is a good way to separate. Now this doesn't look exactly the same, okay, but chemically it is, okay. I know that's kind of hard to believe maybe, and it's kind of confusing because it looks like color change. What happens is this stuff turns blue, greenish color when it dissolves. And I think it's just because it's becoming a little diluted in the water. It's not changing chemically. So this is still copper 2 chloride. So the point is I evaporated the water from that blue solution, and you see copper 2 chloride left over. So again, I did that for period 2, so I'll show that tomorrow. I'll show you it's here. You guys, I'll do the salt water. So this is salt water. What we got going on here is it's called hot water bath. Really, use it for different things. But I put the watch glass on top. The water's boiling. The steam is sort of getting trapped. It's coming out here a little bit. But the steam is hot. When the steam hits the bottom of the watch glass is cooler. So how does the heat transfer there? Well, the water vapor is condensing on the bottom. That's fine. But I'm talking about the heat energy. If you have hot steam hitting the cool watch glass, right? Energy goes hot to cold, right? So the heat goes from the hot water vapor, transfers to the watch glass. The watch glass gets hot. So we pour salt water on top of the watch glass, and we're going to let that sit the rest of the period. Hopefully by the end, most of the water's evaporated. What should we see on top? Salt, okay? So that's just an easy way without evaporating and boiling the entire beaker. If you try and evaporate all this water, what ends up happening is when it starts to boil, salt